Okay, now we'll start with another chapter called as integration. Integration is divided into multiple parts. So we are going to start with the first part of integration, which is called as algebraic integration. Let's first understand the concept of integration. What is integration? Integration is nothing but it is the reverse process of derivatives, right? It is the reverse of derivatives. For example, let us see this. If derivative of A is equal to B, then how do I define integration? Integration is then defined as then integral of B with respect to A, x is A. That means whatever is the answer of derivative, if I integrate that, I will get the question of derivative. Hence, derivative and integration are said to be reverse processes. Fine, do we get this thing clear? So, do we understand the definition of derivative? Definition of integration. If derivative of A is equal to B, then integral of B with respect to x is equal to A. That's how you define integration. Generally, when you write integration always ends with a constant. So all formulas of integration will end with a constant. Now we will start with the first type, which is called as algebraic integration. Let's see the formulas that I will need here. Integral of dx is x plus c. Integral of x raised to n is nothing but x raised to n plus 1 upon n plus 1 plus c. Integral of ax plus b, the whole raised to n, is 1 upon a, ax plus b, the whole raised to n plus 1 upon n plus 1 plus c. So these are the three formulas that I would need for algebraic integration. Let us start with algebraic integration. Integral of 4x cube plus 3x square plus 2x plus 1 with respect to x. Right? Let's see how do I do this sum. Open the bracket. When I open the bracket, integral sign will be multiplied with all the terms. So this will be integral of 4x cube with respect to x plus integral of 3x square with respect to x plus integral of 2x with respect to x plus integral of dx. 4 constant, integral of x cube with respect to x, whatever is constant comes outside the integral sign, plus 3 constant, integral of x square with respect to x plus 2 constant, integral of x with respect to x plus integral of dx. I have just given you the formulas. You will have to use the formula and solve them. For I will be using second formula, integral of x raised to n, which is nothing but x raised to n plus 1 upon n plus 1. 3. Integral of x raised to n is n plus 1 upon n plus 1. 2. Integral of x raised to n plus 1 upon n plus 1. Integral of dx is x. Now all the formulas would have had a c. Instead of writing c multiple number of times, we write the integration constant only once. Instead of writing c here and c here and c here, you instead of writing it 4 times, you will write it only 1 time. So this is going to be 4 upon 4 cancel. So this is x raised to 4 plus x cube plus x square plus x plus c. That will be the answer. Let's see another sum, guys. Integral of 1 upon x square plus minus 2 upon x cube minus 3 upon x raised to 4 minus 4 upon x raised to 5 with respect to x. Let us see this sum. Now, if I open the bracket, this is going to be equal to integral of, I have x square. If I take this in the numerator, the sign of the index will change. So this will be nothing but x raised to minus 2 with respect to x minus constant comes outside the integral sign, x raised to minus 3 with respect to x, minus 3 comes outside the integral sign, x raised to minus 4 with respect to x, minus x raised to minus 5 with respect to x. Now this is going to be x raised to minus 2 plus 1 upon minus 2 plus 1, minus x raised to minus 3 plus 1 upon minus 3 plus 1, minus x raised to minus 4 plus 1 upon minus 4 plus 1, minus x raised to minus 5 plus 1 upon minus 5 plus 1 plus c. In all these cases I have used the same formula. Integral of x raised to n is n plus 1 upon n plus 1. So this is x raised to minus 1 upon minus 1, x raised to minus 2 upon minus 2, x raised to minus 3 upon minus 3, x raised to minus 4 upon minus 4 plus c. So this is minus 1 upon x, 2 and 2 gets cancelled, minus into minus plus 1 upon x square plus 1 upon x cube plus 1 upon x raised to 4 plus c. That is going to be your answer for this. Right? Let's move on ahead. Let's see another sum. Integral of 2x minus 1 and x square plus 3 with respect to x. Right? Let's see this. Now, first let us simplify this. Normal simple expansion. So this is going to be 2x cube plus 6x minus x square minus 3 with respect to x. Open the brackets and simplify. 2 integral of x cube with respect to x, 6 integral of x with respect to x, x square with respect to x, 3 with respect to x. Right? Now this can be written as 2. This is now same formula, x raised to n. Integral of x raised to n is n plus 1 upon n plus 1, n plus 1 upon n plus 1 integral of x raised to n. Same formula again, n plus 1 upon n plus 1. Integral of dx is x plus c. So this is going to be 2 upon 4 x raised to 4 minus plus 6 upon 2 x square minus x cube upon 3 minus 3x plus c. On simplifying this is 1 upon 2 x raised to 4 plus 3x square minus x cube upon 3 minus 3x plus c. That will be the answer. Let's move on to the next sum, people. Integral of 3 minus 2x the whole cube with respect to x. Now let us see the sum. This is in the form a minus b the whole cube. This is a cube minus 3a square b plus 3a b square minus b cube. I am expanding using the formula a minus b the whole cube. So this is going to be integral of 27 minus 9 3s are 27, 27 2s are 54x plus 3 3s are 9, 9 4s are 36x square minus 8x cube with respect to x. Now open the integral sign. So this is 27 integral of dx minus 54 integral of x with respect to x plus 36 integral of x square with respect to x minus 8 integral of x cube with respect to x. So this is 27 integral of dx is x, 54 x is going to be x square by 2. I am using the formula integral of x raised to n. Integral of x raised to n is x raised to n plus 1 upon n plus 1 plus 36 x cube upon 3, same formula again, minus 8 x raised to 4 upon 4 plus c. So this is going to be 27x minus 27x square plus 12x cube minus 2x raised to 4 plus c. That will be the answer, right? Let's move on to the next sum. Integral of 2 minus 5x the whole square upon root x dx, right? Let us see the sum. Expand a minus b the whole square, a square minus 5 to the 10 to the 20 minus 2ab plus b square upon root x dx. Now split the numerator, so this will be integral of 4 upon root x minus 20 of x upon root x plus 25x square upon root x dx, right? Now this can be written as 4 comes out, integral of x raised to minus 1 by 2 dx. Root x is 1 by 2 raised to 1 by 2, and when I bring it in the numerator it will be minus 1 by 2. Minus 20 is a constant, comes out. X upon root x will give you root x in the numerator, which is x raised to 1 by 2 plus 25 integral of x square upon root x is nothing but x root x, right, which is nothing but x raised to 3 by 2 dx. Now this can be written, you use the formula integral of x raised to n plus 1 upon n plus 1 upon n plus 1, same formula guys, 3 by 2 plus 1 upon 3 by 2 plus 1 plus c. Now this is going to be 4x raised to 1 by 2 minus 1 by 2 plus 1 is 1 by 2 upon 1 by 2 minus 20 x raised to 3 by 2 upon 3 by 2 plus 25 x raised to 5 by 2 upon 5 by 2 plus c. Now this can be simplified as denominator becomes numerator, so this will be 8 root x, right, minus 40 upon 3. How 40? 20 into 2. Denominator of denominator becomes numerator. X raised to 3 by 2 is nothing but x root x plus 25 twos are 50, 50 divided by 5, 10 x square root x plus c. X raised to 5 by 2 is nothing but x square root x. Fine. Let's move on to the next one, guys. Integral of 4x plus 1 into 3 minus 5x square upon x root x with respect to x, right? Let us see the sum. Now first let us expand this. This is going to be 4 3s are 12x minus 4 5s are 20x cube plus 3 minus 5x square upon x root x with respect to x. Now this can be written as integral of 12x upon x root x. I am splitting the numerator, people, dx minus 20x cube upon x root x plus 3 upon x root x with respect to x, 5x square upon x root x with respect to x. So here x and x gets cancelled. This is 12. Root x is x raised to 1 by 2. When I take it in the numerator, it will become x raised to minus 1 by 2 dx minus this and this gets cancelled. So x square. X square upon root x is nothing but x root x, which can be written as x raised to 3 by 2 dx plus 3 x root x is x raised to 3 by 2. When I bring it in the numerator, this will be x raised to minus 3 by 2 dx plus, no, minus 5 integral of, this is nothing but x upon root x, which is root x, which is x raised to 1 by 2 dx. Fine, do we get this thing clear? Now, this can be written as 12. Same formula, integral of x raised to n is x raised to n plus 1 upon n plus 1. So, minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. Same formula again, 3 by 2 plus 1 upon 3 by 2 plus 1 plus 3 minus 3 by 2 plus 1 upon minus 3 by 2 plus 1 minus 5 1 by 2 plus 1 upon 1 by 2 plus 1 plus c. Now this is going to be 12 x raised to 1 by 2 upon 1 by 2 minus 20 x raised to 5 by 2 upon 5 by 2 plus 3 x raised to minus 1 by 2 upon minus 1 by 2 minus 5 x raised to 3 by 2 upon 3 by 2 plus c. Let's complete this sum up there, guys. Let's complete this sum up there. So this will be 12 2s are 24, x raised to 1 by 2 is nothing but root x, minus 22 are 40, 40 divided by 5 is 8, x raised to 5 by 2 is x square root x, plus into minus is minus, 3 2s are 6, x raised to minus 1 by 2 is upon root x, minus 5 2s are 10 upon 3, x raised to 3 by 2 is x root x plus c. So that will be your answer, right? Let's move on to the next one, people. Integral of 2x plus 7 the whole raised to 5 plus 1 upon 7 minus 2x the whole raised to 5 dx. Right? Let's see the sum. This can be written as integral of 2x plus 7 the whole raised to 5 dx plus integral of, take the term in the numerator, so it will be minus 5. Rearrange the term, this can be written as minus 2x plus 7 raised to minus 5 dx. Right? I just rearrange the term, I wrote this as minus 2x plus 7. Since I am taking from the denominator to numerator, I am changing the sign of the indice. Now, I could use the third formula here. Integral of ax plus b raised to n is 1 upon a. The number with x is called as a. So 1 upon a, ax plus b raised to n plus 1 upon n plus 1 plus 1 upon a, ax plus b raised to n plus 1 upon n plus 1 plus c. So this is 6, 6 2s are 12, 1 upon 12, 2x plus 7 raised to 6. Now, this is going to give you minus 4. Minus 4 into minus 2 is plus 8. So, this is going to give you 1 upon 8 minus 2x plus 7 raised to minus 4 plus c. That will be your answer. Let's move on to the next sum, guys. The last sum to finish this type. Integral of root of 5 minus 3x plus 1 upon root of 3x minus 5 dx. Right? Let's see the sum, guys. This can be written as integral of, rearrange the term, minus 3x plus 5 raised to 1 by 2 dx plus integral of 3x minus 5 raised to minus 1 by 2 dx. Denominator to numerator, sign of the index changes. Square root is raised to 1 by 2. Same third formula, integral of ax plus b raised to n is 1 upon ax plus b raised to n plus 1 upon n plus 1. Similarly, this is going to be 1 upon ax plus b raised to n plus 1 upon n plus 1 plus c. So this is minus 1 upon 3 minus 3x plus 5 raised to 3 by 2 upon 3 by 2 plus 1 upon 3 3x minus 5 raised to 1 by 2 upon 1 by 2 plus c. So this becomes minus 2 by 9 minus 3x plus 5 raised to 3 by 2 plus 2 by 3 3x minus 5 raised to 1 by 2 plus c. So that will be your answer. This finishes this chapter. Let's stop here for a day. We'll continue with this in the next lecture. Thank you.